So those are the three important ones that we come across. Obviously, there's lots of other toxic metals. You've got lead, you've got cadmium, and you've got silver, can be toxic sometimes. There's hosts of toxic metals, but remember the main reason a metal is toxic is because it displaces the good one, and there are certain predispositions to some because their chemical and physical properties are similar. Many active sites on enzymes where the enzyme actually works, the apo part of the enzyme, is the sulfur amino acids. Cysteine, methionine, cysteine are the major amino acids which are sulfur-bearing, and they like to bond on to these sulfur-bearing acids. So toxic metals such as mercury always attack these sulfhydryl bonds. So there we've got the main ones. So we've got methionine, cysteine, and cysteine. Glutathione is a tripeptide and doesn't actually make up proteins. And taurine is the most abundant amino acid in the body, but again doesn't make any proteins. Okay? So it's a very great detoxifier, taurine, but it's not a building block amino acid for building proteins. So metals that have transient charges, in other words iron and copper, are capable of inducing oxidative stress directly. Now this is very important in the presence of oxygen, so you don't want to increase oxidative stress or free radical formation when we liberate iron and copper having had a hemorrhage. So this is why when people have had strokes, hemorrhagic strokes, you should never have them exposed to copper or iron because it will increase the oxidative damage. And this is why with multiple nutrients, many companies do a nice multiple for people as they get over certain ages, but they will sell you one without copper and iron. Okay? And it's not because they're cutting the costs. So a multiple without copper and iron is there for a reason. Not because you've got a stroke, and if you've had a person with a stroke, then obviously you don't give them iron and copper, but in case they get a stroke. So if you've got a high-ish level, optimal level of copper and iron, and you hemorrhage, and you've got a high level of free copper and iron in your blood being transported, it will do much more damage than the person who's actually got low iron and copper. Now, iron and copper are essential nutrients for their own reasons. So I'm not saying you don't have any iron or copper in the diet, but if you're going to give a person an optimal level and perhaps put on a multiple, probably when they get to 50, 60, better to use a multiple without copper and iron for that reason. Okay, so there's the two forms. So we've got the ferric and ferrous, and the cupric and the cuprous form of the copper. Here we got the reduced one with the extra electrons, so we got less positives, and here we got the oxidized because we've got less electrons. So colours, we've looked at colour cones that a person weakens to gives an indication potentially of the toxic metal, but sometimes there's other metals there as well. So you see here, every element in the universe has a spectroscopic emission and a spectroscopic absorption. And when an element is put in an excited state, in other words, it's heated or exposed to a lot of light and energy, electrons will move from the outer orbit to a further orbit. Okay? This is called an excited state. And when those electrons from the excited state go back down into what's called a ground state, they emit a package of light. And that package of light is called a photon. Okay? And that's what we see as light. So a photon of light is not a particle, although it behaves occasionally as a particle when it's observed, but it moves from the outer orbit to the lower orbit, the ground, and as it does that, it emits a package of light called a photon. Okay? The amazing thing is, no scientist has seen it move. Okay, so it will go from the outer orbit to the ground state orbit without going between the two. Okay, and that's what's called a quantum leap. That's what quantum mechanics is about. So it moves from there to there, and nobody knows where it's gone. Now, some quantum scientists will say, at a brief moment, it was over the other side of the universe, and then it came back again. But nobody really knows. That's called superposition and all sorts of things. So it's a fascinating subject, but quantum leaps mean nobody sees what happens in between. So when we push it into a heightened state of energy, it has to be exposed to heat as an energy or light. And this is for the same reason why with Anna there, when we tested with the marker, I tested with the marker, can I have you back a minute? With the marker onto her skin with the light. Now, if the light is not good, the challenge may not work. So just as we saw with the red acetate, if we put the marker for the aluminium here on her and she goes weak, if we cover that over, in other words, no light goes into the marker, she doesn't go weak. Okay? Because it's not in an excited state. To get it into an excited state, to make it work, you have to have light, or put it into heat or light. Right? So now, if you wrap that in your hand, what's that going to do? You've missed it. She could be poisoned by aluminium, but you wouldn't see it if you do that. Okay, so we suggest you don't do that with your test files. Okay, maybe that, but not that. Okay, but it's best, as we saw, like with the red acetate, round here in the upper abdomen there is quite good. You know, you get a reasonably good weakness. As we go down there, we get a better one. But when we come under the umbilicus, we get a tremendous one. It's almost as if you switch off completely, isn't it? Okay, so around the umbilicus is actually weaker in many ways than around the eye. See, it's quite hard in comparison around the eyes. You know, the difference there, I can overpower you, but it's harder than here. Here is actually more sensitive. Now, why do you think that is? It's not interesting. Why is that? So we'll see when we look in neuromodulation lecture, which will be here in July, exactly why that is because there's a lot of blood under there. This is where all your information went in, all your blood, and now it's still an area of high blood in the umbilical region, and we're only about an inch from there down to the aorta, which is the biggest supply of blood. Okay, and what does blood contain? Hemoglobin. And what did I tell you? The property of heme is it's light sensitive. All right, and light sensitive means it likes light or it hates it, depending upon the wavelength. Okay. Francis Crick was the first person to actually observe this, Crick and Watson, but Francis Crick was a neurobiologist, and he noticed with traumatic brain injury people that neurons would be attracted towards certain wavelengths and repelled by other ones. So they were using in the late 1990s fiber optics into brain of people with traumatic brain injuries to liven the brain up by using certain wavelengths of light. And this is what happens here. This is a light coming from outside into your body, which you say, I don't like that, okay? And it's switching all your switches off, okay? And it switches off more around the umbilicus than it does actually through the eyes. Okay, so the main thing is when you test, you have to put the test kits into an excited state, which means you have them in the light. So put them on the body, wherever you want to put them, but don't cover them over, all right? Because they just won't work in the same way. Okay. Right, so here we see the spectroscopic emission and absorption. So in the ground state, what happens is it absorbs certain wavelengths of light, and the emission, it actually gives that same wavelength of light. So this is like the reverse. It's the opposite, equal and opposite. So this one, it's taking these wave bands of light, so they're black, because it's taking it in and absorbing, and here we see the color. And you'll see the biggest line with aluminium is at 619 nanometers, which is exactly the same color as the wave, as the red cone. In the same way that you'll find with the green, gives the nickel with the biggest band there, and the same way with the mercury. See how big the line is with the mercury? In the same way. This is why red, green, and blue people are very sensitive towards those metals. It's almost as if they're bonded together. So let's have a quick look. Aluminium, salt in tap water, is a deflocculant. It's an antacid, anti-inflammatory, anti-diarrhea. Aluminium silicates in medications, all food wrapped in aluminium foil, particularly if it's heated. Your takeaways, etc. there. Oxocubes, not quite so bad because it's dry. Things that are in aluminium that are dry are not a problem. It's when they're liquids. Insides of milk and fruit juice cartons contain often aluminium. They can line with plastic as well, but if the plastic gets cracked because it gets bent, it can then leak aluminium. Takeaway cartons, aluminium food, soft drinks and beer cans, of course, are really good, particularly if the soft drinks and beer have been in the sun for a bit, and then cooled. So often they put them outside, they get warmed up, and then they put them in the fridge. And that's got a lovely, nice dose of aluminium in there. Squeezy tubes, such as tomato paste, baking powder, self-raising flour, salt and certain food additives, naturally high levels in tea, spearmint and peppermint teas. Tea bags, instant coffee, spinach, potatoes and processed cheese. These naturally take it up from the soil. Deodorants, antiperspirants, skin lotions, makeups, douches and toothpaste, saucepans, frying pans, kettles. And the kettle is the main one of probably all of those to remember. Okay. So nickel for the green people. Sunflower seeds. Sunflowers have a natural affinity taking up aluminium. Licorice, hydrogenated oils, because the hydrogenation uses nickel as the catalyst. Okay? We came across this in exhibition, didn't we, last week, of somebody who was hydrogenating vegetable oils to make very nice butters. Lovely butters for the cosmetic and toiletry world. They were good enough to eat, I thought. And then I realized no. And she said, oh, we hydrogenate them just to make them thicker, but they're natural oils. And I said, oh, lovely, very nice. What do you use as the catalyst? She said, oh, nickel. So I thought, not for me. Okay, give it to a red or a blue, but not for a green. Watch straps and glasses. Rolled oats. Stainless steel is actually 7% nickel. So potentially it could leak, but things like rollers can leave a little bit. Non-silver or gold jewellery, such as earrings, a lot of nickel in the alloys there. Dental fillings and retainers may have some. Cooking utensils and cappuccino machines, because of stainless steel and the heat. Nickel cadmium batteries, not likely to eat those unless you're pretty desperate. Cosmetics and permanent waves. Tobacco smoke. Remember the old VDU computers? You're not old enough to remember. And television sets and VDUs, they used to give off a nice lot there. So if you sat there with a cigarette and you were working on a big VDU, you're classic of getting the nickel toxicity there. Industrial explosion, ceramics. And superphosphate fertilizers. So try not to breathe that stuff in when you go around your garden once every 3 years to put it up. So mercury, as we can see here, probably the deadliest of all these. Generally speaking, the heavier the metal, the higher up the periodic table it is, the greater the number it is in the periodic, greater the atomic weight, the harder it is to get out of the body. Okay? So certain metals like aluminium will get out quite quickly. Once you stop the source of it, get a bit more water into you, some vitamin C, you'll start to flush it out quite quickly. Mercury is a different matter. Mercury in the system, in the systemic part of the body, has a half-life of 72 days. So when you've had a filling extracted or an exposure to it, 72 days, 50% of it will gone in the majority of people. Mercury in the brain has a half-life of 27 years. Only superseded by cadmium, which has 37 years. Okay? So when you're exposed to cadmium, it's going to take a long time to get that out. But as far as the mercury, generally speaking, in the blood, it's not such a big problem in the lymph and things. But once it crosses the blood-brain barrier and it's in the brain, it's a big job. It's a lot longer to get it out. So dental amalgams, high fructose corn syrup. This is now considered to be one of the major sources of mercury in the world, particularly obviously in the US, where they use a lot of corn syrup as a sweetener. Sanitary towels, cotton balls and buds, dental floss, toothpicks, paint, explosives, you probably don't have too many now, batteries, mercurial diuretics, fungicides, laxatives, hemorrhoids, fluorescent lights. A lot of the new bulbs, the daylight saving, are mercury vapor in them, aren't they? So that mercury vapor comes out at the same wavelength of light as blue people. So if you've got a blue person here and you get them then to look at an energy-saving bulb there, not a bright one, although they probably go weak anyway, but on an energy-saving bulb, with the mercury tubes, because you shouldn't chuck those in the bin, should you? They're dangerous material now. You have to do special bins. People weaken. So if you work in an environment and you're a blue and you work with those, it doesn't do you any good. A lot of people get headaches and all sorts of things because they're having the colour that weakens them in a low luminosity. They don't see it. It looks like white light, but it's of a low luminosity constantly coming at them. Estelle's like that, isn't it? She can't go into certain shops. Certain supermarkets drive her insane. And other ones are perfectly all right, aren't they? And you thought it was to do with the brand. but it's actually to do with the lighting in the sharp reading scope. It's a bit of both. Okay. Hair dyes. What was it? The something 2000. We won't mention any names. Fiberglass, manufacture and delivery of petroleum, sewage sludge, methyl mercury, chlorine bleaches. So you see it's in a lot of things in small amounts. Inks used by printers and tattooists. Most tattoos are mercury toxicity, so where they will leak over a period of time, some paints. Some salt, fish in contaminated waters, particularly, of course, they blame the old tuna there, and vaccines, of course, with thermal aerosol. So other ones which we found are less toxic but associated with the red, green and blue people that you might think of, and this works really quite well, is the red cone people, lead, fluoride. Fluoride is not a metal, so we shouldn't really cut that. Indium, palladium, copper, manganese and vanadium. Blue cone people, mercury, gallium and thallium. Well, thallium is a contaminant of mercury, so it's not surprising that it's in there. And green is arsenic. Again, arsenic is not a metal, but it is a toxic substance, all right, and cobalt. So they all have these big spectroscopic emissions and absorptions in the same wave band as the red, green and blue cones. So diagnosis of a toxic metal, any enzyme pathway which exhibits acquired inhibition. So potentially anything which doesn't function in the way that it should do, in other words, you strengthen to the end product, weaken to the substrate, potentially could be deficient in a coenzyme or cofactor, and have a toxin inhibiting it from functioning. Okay? So we've always got to see two sides of the coin. Now the easiest way to find that is obviously to do the eye positions, because if toxins come up, you've got to identify what the toxin is. And if that toxin is a metal, then you need to get rid of it. The most common meridians where people have real problems getting rid of them is the bladder and the kidney. Because toxic metals, there's only one way you can get a metal in, which I described in the previous session, which is as an ionic solution. You cannot absorb a lump of zinc. You have to put it into solution. And in exactly the same way, you have to put it into solution to get a toxic metal in. You can't swallow mercury, but you can swallow mercury in solution, okay, as an ionic. So therefore, the natural way the body gets rid of these is through the water channels. So plenty of water is good. So the two meridians, which will be the key ones if a person shows up positive on a kidney or a bladder meridian, they've got a much greater predisposition towards absorbing and holding on to toxic metals. So bless them, but that's not their fault. You know, that's the genetics, that they're predestined, if you like, to always be looking out for this if they've got a kidney or bladder weakness in that way. Positive meridian will be negated by the toxic metal nocide. So like the chemical nocide is a composite of all the toxic metals in the kits. So this would include not only the mercury and the nickel and the aluminium, but all the arsenics, the palladiums, the vanadiums and so on. So everything is in there which is toxic in that marker. So this is not a therapy, this is a marker which we use, as we'll show you with the starter kit. You can use it from weakness or from strength because it's homeopathic, so it'll do both. So if it responds to the enzyme pathway, then you know there's an issue there. Patient will weaken to a specific toxic metal, so if you've got the aluminium, mercury, etc., then you can do that. So it's best to test with full strength toxic metal solutions from strength to weakness, or you can use the homeopathics. Treatment, often the best chelating agent. Chelate means to chlor, okay, to chlor it out. So what we're doing basically is we're chloring off the toxic metal off the enzymes where they're deposited. The chelating agent is adjacent to the toxic metal in the periodic table. So one above or so, one below, one left, one right, one diagonal is probably going to be the best displacer of it. Herbs, spices, etc., to actually chelate, from our point of view, you know, many of these are very effective, but you have to muscle test which is the main one. Black walnut tincture, excellent. We know it from previously for parasites, but it's a great detoxifier. We don't know why, but it obviously has an effect on upregulating the ability, might have diuretic effects. Coriander herb, or cilantro as it's sometimes called, is an excellent, that's green coriander, that's the great one. But you shouldn't really use that one if you've got mercury amalgams, because it will dissolve your mercury in your mouth. So it's better to take it as a capsule and swallow it down so you bypass. If you take it as a tincture, particularly if you swill it around in the mouth, you may actually leach mercury. because it's very effective at doing that. So people with amalgams shouldn't really eat coriander herbs. Okay, so if you have coriander in a dish, you shouldn't really have it and chew it and swallow it straight down. Better to avoid it. Coriander spice, on the other hand, is fantastic also. Very rarely, unfortunately, do people show to coriander spice and herb. So I've always wanted to think, if I could blend the coriander of both, but they don't. People seem to correspond, who've got toxic metals, to one or the other. But coriander, both of those are excellent detoxifiers. Lemon balm, again, very, very good, which we talked about before. Alpha-lipoic acid, for the reasons we described, because it's a sulfur-bearing amino acid. And yarrow, which is good for chemicals and toxic metals. Glutathione when it's really bad. Vitamin C is excellent, specific with nickel. And, of course, if all fails on everything else, NAC. But remember, take NAC for anything up to a few days, few weeks even, but not more than months, otherwise you may flush out the good guys. Toxic metals in the water-soluble components of the body will chelate out easily with any of the previous nutrients. So water-soluble components. Now, the difficulty is when they get into the fat-soluble bits that you may need something much more of a solvent, such as an alkyl glycerol, or chlorella is very good from algae. So you may consider chlorella as a detoxifier of metals. So I personally recommend chlorella because it bonds onto mercury when people have amalgam extraction. So they have 2 caps immediately before the extraction, because we're talking about mercury particles and things in the gut. So you swallowed a little bit of dust and things from the extraction process. You want something for it to bond on. So 2 capsules immediately before extraction, 2 caps immediately after the extraction, and 2 caps about an hour later. Right? So only about 6 caps altogether. It's quite a cheap process. Some people sometimes like to give a large dose, 1 or 2 grams of vitamin C the day before, during and afterwards as well. But we find chlorella is very good for that. And liquid selenium. This is an aqueous solution of sodium selenate, which is what we do, as a mouthwash during the amalgam extraction. Selenium will lock onto it and bond onto mercury, and then you spit it out. You don't want to swallow it, but you spit it out after it. So take a 100 ml bottle with you if you're going to have it, and just give it to the dentist. They won't mind. And you pour it into that stuff that they give you,